An alien entity has entered our celestial neighborhood. It arrived like a phantom vessel, adrift on the cosmic expanse, a mass of luminous metal and ice traversing the emptiness. The trajectory of 3 Atlas wasn't coincidental. Each inclination, each deviation, appeared meticulously charted by an unseen hand. If the universe is an ocean, this is a ship, and we stand on the shore, observing its direct approach. The query isn't when it will reach us, but why. If you're ready to witness our galaxy in a new light, please indicate your appreciation and subscribe. Our exploration commences presently. On a tranquil night in July, high above the volcanic peaks of Hawaii, beneath the rarefied air, the Atlas Observatory detected an object moving with unnatural speed and certainty, clearly not of our solar system. Scientists focused their instruments. The anomaly didn't curve like a comet, nor meander like an asteroid. It traced a singular, unwavering path, a precise incision through the solar system, as if guided by intent. For a moment, silence pervaded the control center. Then, the dawning comprehension. This was no local anomaly. It was a visitor from the chasm between stars, a harbinger from the interstellar void. It would later be catalogued as 3 Atlas, the third confirmed interstellar visitor. However, designations can't fully encapsulate its nature. Envision, instead, a mountain of rock and metal, 6 miles in diameter, hurtling through space at an astonishing velocity. At that speed, it could traverse the distance between Earth and the Moon in under 5 hours. Picture Mount Everest detached from our planet, silently gliding between the orbits of Mars and Earth. Such is the magnitude of this traveler. Even the Sun's formidable gravity, capable of dictating planetary orbits, cannot impede its progress. 3 Atlas does not orbit. It is an escapee. Data from observatories in Hawaii, Chile, and Spain corroborate the extraordinary. Its path is hyperbolic, its eccentricity exceeding 1, the mathematical hallmark of an interloper. It emerged from the direction of Pegasus, piercing the cosmic dust like a silent blade. The numerical evidence was unequivocal. Its origin was interstellar. And if its trajectory defied gravity, what of its composition? We had tracked its passage through our solar system. Now, our attention turned to the traveler itself. What was this entity that dared to traverse the void between stars? What was its substance? Initial measurements presented a puzzle. The object defied conventional proportions. It was neither a fragment of ice nor a shard of rock. 3 Atlas revealed itself as a colossal mass, a drifting island of matter, 6 to 9 miles wide, navigating the solar sea. Telescopes discerned its faint luminescence and calculated its dimensions. The light it reflected was neither the deep blackness of carbon nor the sharp glint of frozen water. It possessed an intermediate quality, akin to metallic dust encased in frost. Such scale challenges comprehension. Imagine Manhattan Island, hewn from solid rock, drifting silently between Mars and Earth. Imagine Mount Everest, ripped from its terrestrial anchor and set adrift in the darkness, rotating once every 11 hours. This is the physical scope of 3 Atlas, an island the size of a metropolis, yet moving at speeds surpassing any human-engineered craft. Natural comets rarely attain such dimensions. The colossal comet Hale-Bopp, visible in 1997, spanned 46 miles across, a frozen behemoth from our own Oort cloud. Yet, encountering an object even a fraction of that size originating from another star system is statistically improbable. In all models of interstellar detritus, larger masses are the first to disintegrate, shattered, dispersed, decelerated. Nevertheless, this one travels at escape velocity, intact and unbroken. A survivor of the interstellar gulf, spectroscopic analysis further deepened the enigma. There was no distinct signature of volatile ices, the kind that imbue comets with their luminous tails. Instead, faint traces of iron, nickel, and silicate minerals were detected, materials forged deep within planetary crusts. If these readings are accurate, then 3 Atlas is not a loose conglomeration of frozen gases, but a core, the heart of something once more substantial, a fragment of a celestial body, or perhaps something artificially constructed. And then arose the question that silenced even the torrent of data. Where did it originate? Its inbound vector points toward Pegasus, near the star 51 Pegasi, the first star discovered to host an exoplanet. Could it have been ejected from there by a dying star or a cataclysmic planetary collision? Or, more disturbingly, could it have been dispatched? Astronomers rewound its trajectory through simulated millennia. Even with sophisticated instruments, precision diminishes beyond 10 light-years. The path dissolves into a mathematical haze, much like a ship's wake dissipates on the open sea. All we can ascertain is that it originated from the general direction of the galactic disk, the same plane where most known inhabited systems are located. Is this coincidence or deliberate design? A few quiet observations noted further anomalies. The ratio between its mass and reflectivity was unusual, too dim for a comet, too bright for an asteroid. Its surface appeared smooth, potentially metallic, even exhibiting layering. Such characteristics suggest manufactured origins rather than natural erosion. However, caution prevailed. The data was sparse, the signal faint. 1,000 mundane explanations can mimic extraordinary phenomena. Nevertheless, its uniformity unsettled experienced observers. Its steady rotation, its unchanging luminosity, its refusal to shed debris even as it approached the sun's warmth. In the hushed control rooms, researchers monitored the numerical readouts: velocity, inclination, albedo. Each digit represented a moment of profound mystery, and beneath the rigor of scientific observation, a persistent murmur arose. If nature sculpted it, what crucible was powerful enough? If it was fashioned by intelligent hands, where are they now? 3 Atlas offers no response. It continues its flawless trajectory through the darkness, leaving us to ponder whether we are witnessing a mere cosmic accident or the imprint of intention, and what forces might have shaped its course. Matter tells one story, but its movement narrates another. Because as we finally charted the path of 3 Atlas across the heavens, its journey appeared less like aimless drift and more like purposeful progression. When scientists first mapped the trajectory of 3 Atlas, something within the data felt amiss, almost calculated. Its orbit was not a closed loop, but a clean, open arc, a hyperbola, the geometric symbol of escape. In the language of celestial mechanics, this curve carries profound meaning. It signifies, "I do not belong here." Every natural celestial body, planets, comets, asteroids, follows the sun's gravitational pull in elliptical paths. 3 Atlas defied this, slicing through the solar system on a trajectory so precise it seemed deliberately inscribed, obeying no influence but its own. Its entry vector originated from the vicinity of Pegasus, that mythical constellation of wings and flight. It traversed Neptune's orbit, then curved inward, brushing past the pathways of Mars and Earth. The deflection caused by the sun's gravity was minimal, graceful, and precisely measured, devoid of chaotic deviation. Simulations indicate that as it departs, its course will be directed toward Lyra, another celestial emblem of flight. Pegasus to Lyra, wings to wings. It's as if a message were etched across the cosmos. At its core lies a fundamental question of energy. To maintain a velocity of 130,000 miles per hour, a body 6 miles wide would require immense propulsive forces. Perhaps a supernova, a gravitational slingshot from a gas giant, or something engineered. Even the most extreme natural accelerations strain the limits of physical possibility. Yet, 3 Atlas remains intact. Its rotation is stable, its surface undisturbed. This composure unnerves astronomers. It is the kind of consistency one associates with deliberate design, not random chance. Every few days, new data arrives from Hawaii, Chile, and Spain. Each observation refines its projected path by fractions of an arcsecond. There is no wobble, no visible tail, no jets of outgassing. It moves with the precision of a machine following pre-programmed instructions, a probe tracing a predetermined line. To human observers, it feels almost rehearsed. At its perihelion, its closest approach to the Sun, it will pass approximately 167 million miles from Earth. While this distance seems vast, in cosmic terms, it is close enough to convey a whisper. And at that precise moment, the Sun will position itself directly between us and the object, obscuring our view. For several days, 3 Atlas will vanish, hidden behind the blinding solar glare, invisible even to the most sensitive instruments. By the time it reemerges, it will already be on its outward trajectory. Some interpret this as mere coincidence, others as deliberate choreography. Astrophysicists maintain it is chance, a mere 0.8% or 5% alignment dismissed as the whim of probability. Yet, the perfection of the timing continues to captivate the imagination. If its trajectory were natural, one would expect it to tumble, flare, or shed debris. Instead, it moves with an unruffled serenity, unwavering, as if aware of being observed. Even its rotational period, 11 hours and 32 minutes, is disconcertingly precise. Not chaotic, not drifting, but balanced, centered, and repetitive like a heartbeat. This is the kind of rhythm engineers design, not nature. And as the data streams in, the silence in observatories deepens. We can describe its movement, but not its motive. Soon, 3 Atlas will complete its solar passage and recede into the distance. Its light will dim, frame by frame, until only the background stars remain. But the record will endure. A perfect curve etched across our solar system, a signature imprinted with purpose across the canvas of space. And within that steady, silent, unhurried motion, some claim to perceive intent, like an echo of a choice made light years away. When the initial data suggested purposeful movement, the question became unavoidable. Who among us would dare to voice it? Across the patient halls of science, one voice consistently rises when the cosmos presents anomalies. Avi Loeb, chair of astronomy at Harvard University. He is the individual who persistently probes what others relegate to late-night speculation. In 2017, as the first interstellar visitor, Oumuamua, skimmed past the Sun, he articulated the unspoken thought. Everyone else was silent. Perhaps it was constructed, not born. 8 years later, with 3 Atlas blazing along its impeccable trajectory, Loeb's voice cuts through the cautious discourse. The figures on his screen are deceptively simple. A 6 to 9 mile wide object, a flawless hyperbolic path, unwavering rotation, an absence of gas or dust. Each individual measurement falls within the realm of physics, yet collectively, they sketch a disquietingly precise picture. Nature, he argues, improvises. This object performs. From his office overlooking the Harvard Yard, Loeb weighs chance against design. Roll the cosmic dice, he asserts, and the probability of a random rock crossing 4 planetary lanes, meeting the Sun at just the right alignment, and escaping unharmed is approximately 1 in 20,000. That fraction, 0.5%, is small enough to make coincidence feel almost deliberate. He terms it geometry disguised as luck. Possible narratives unfold on the blackboard behind him. One depicts a traveler launched eons ago, programmed to glide past inhabited worlds, gathering discrete data as it uses planetary gravity like stepping stones. Another suggests a returning visitor, tracing an orbit so vast that its previous passage is recorded only in legend or buried within the faint glow of ancient radiation. A third theory portrays it as a patient probe, utilizing Jupiter's gravitational pull to decelerate, choosing to remain rather than depart. None of these hypotheses defy scientific principles. They expand them, making room for wonder. Loeb refers to this as the hallmark of a useful hypothesis, extraordinary, yet still testable. He never claims definitive proof. He simply refuses to close the door. Nature writes in chaos, he states softly, but technology leaves straight lines behind. Skeptics retort with a demand for discipline. Imagination, they remind him, is not evidence. They desire spectral signatures of carbon or nickel, something tangible, something safe. Loeb smiles, a smile reminiscent of explorers from an era when maps still had unexplored edges. Safety, he replies, has never led to new discoveries. Outside, dusk settles over Cambridge. The lamps in the yard glimmer like miniature suns beneath the real ones rising beyond sight. Somewhere out there, 3 Atlas continues its silent transit, steady, indifferent, precise. And in a single illuminated office, one scientist continues to watch, not because he possesses certainty, but because curiosity, not assurance, is the engine of discovery. A trajectory can reveal a story. Every speck of dust, every moon, and every wandering planet adheres to the same invisible script, gravity's calligraphy across the void. Yet, when scientists traced the path of 3 Atlas, this script appeared unnervingly refined. The curve was smooth, precise, unbroken. It bent only where gravitational forces dictated, as if the coordinates had been inscribed long before humanity mastered celestial charting. For Avi and his quiet circle of collaborators, this symmetry holds significant weight. They refer to it as the calculated trajectory hypothesis, suggesting that 3 Atlas is not a random wanderer, but a constructed observer, moving along a deliberate route through the solar system. In their models, the traveler enters from Pegasus, navigates near Mars, grazes Earth's orbit, then glides past Venus and Jupiter before venturing back into the darkness. The probability of such a pattern arising by chance is infinitesimally small, approximately 0.05%, the same figure that has consistently appeared in every analysis of this visitor's path. 4 planetary flybys, each close enough for scientific study, yet each distant enough to avoid peril. This is the kind of path a cautious intelligence might devise, curious yet remaining unseen. At the Smithsonian Center for Astrophysics, simulations lend credence to this theory. A probe following such a route could meticulously scan magnetic fields, plasma streams, atmospheric scattering, and even the faint radio emissions emanating from Earth. Gravitational assists would efficiently conserve energy, adjusting its momentum with elegance rather than brute force. The mathematics depict not randomness, but efficiency, a geometry imbued with purpose. Skeptics, however, counter that efficiency is nature's inherent language. Gravity, they argue, composes poetry without a poet. But Loeb's team points to another crucial clue: phase coherence. Most comets exhibit wobbles and erratic movements as solar warmth intensifies. 3 Atlas, however, does not. Its rotation, precisely 11 hours and 32 minutes, remains constant, as if locked in place by design. This unwavering stability keeps one face oriented, as though a sensor were perpetually observing. Some models suggest subtle self-corrections are possible, minute gas expulsions or internal mass shifts imperceptible against the background noise of the solar wind. Over centuries, such minute adjustments could guide its course, akin to invisible hands on a celestial rudder. Other theories delve further back in time, envisioning an ancient probe, the remnant of a cosmic network that once spanned the stars, a relic still adhering to a long-forgotten directive: observe and report, even if no one is listening anymore. In Cambridge, Loeb leans closer to the equations scrolling across his screen. Lines of motion intertwine like brushstrokes, converging near Earth's orbit. His voice drops to a murmur. "It moves," he says, as if someone intended it to be noticed, but never truly understood. Beyond the data, imagination takes flight. The arc of the orbit begins to feel like the curve of intent, a message communicated not through language, but through motion. Regardless of whether its author was alien, ancient, or purely gravitational, the outcome remains the same: a presence traversing our cosmic neighborhood with quiet precision. Soon, 3 Atlas will pass behind the sun, disappearing for weeks into its blinding glare. When it reemerges, the data may confirm nothing, or it may confirm everything. But one thought now resonates in every observatory, every mind tracing that perfect line through the void. Somewhere, someone performed the calculation. And once you realize this, the universe feels far less empty than it once did. The longer the data streamed in, the quieter the universe seemed to become. Each new plot of 3 Atlas made its silence feel deliberate, an eloquence of absence. It drifted through the solar system like a moving shadow that actively avoided illumination. Even when telescopes were precisely aligned with its path, the object remained faint, its brightness fluctuating in and out of detection, as if it were choosing when to be observed. When astronomers overlaid its motion with solar geometry, a pattern began to emerge. Every moment of peak visibility coincided with blinding sunlight. It was almost as if Loeb murmured, it had learned to conceal itself. In celestial mechanics, this alignment is termed solar conjunction, the precise instant when the sun positions itself directly between Earth and another celestial body, overwhelming sensors with light and rendering data into static. Spacecraft lose radio communication during conjunction. Astronomers lose visual contact. But 3 Atlas appeared to have deliberately selected this very obscurity as its cloak. At its closest approach, approximately 167 million miles from Earth, the sun lay perfectly between us. Of all possible trajectories, why choose the one that obliterates vision at the most critical juncture? Loeb's reply fractured the room. Perhaps, he suggested, this geometric alignment was not an accident, but a deliberate design. A reconnaissance craft could indeed use the sun as a shield, observing inner planets, while its reflected light and any emitted signals dissolved into the solar glare. To hide within light, he stated quietly, is the most elegant form of camouflage. Skeptics countered that orbital dynamics are inherently impartial. The sun obscures thousands of objects annually. Yet, the probability returned once more, the same persistent 0.05% figure that threads through every analysis of this visitor's trajectory. Whether random or not, the numbers persistently whispered of a pattern. Photometric data deepened the mystery. As 3 Atlas neared its perihelion, its brightness did not surge. There was no outburst, no flare, no visible tail, Its albedo remained constant even as solar radiation intensified, a composure that defied all expectations for an icy celestial body. If it were a natural object, heat should have caused gas and dust to peel from its surface, altering both its luminescence and its course. Instead, it remained steady, disciplined, almost wary. Loeb suggested that this stillness was more than mere physics, it was behavior. "It hides in light," he told the BBC. "That's how caution appears when traveling between stars." This remark shifted the debate from astronomy to psychology. For the first time, the universe felt less like an indifferent machine and more like a conscious entity aware of being observed. Even among those who dismissed his hypothesis, a sense of unease began to creep in. The maneuver bore a resemblance to tactics our own probes might employ when approaching a potentially hostile world. Slip behind the star, gather data, depart undetected. Official reports remained cautiously worded. NASA's Jet Propulsion Laboratory described the pattern as intriguing but unverified. Nevertheless, in private seminars, researchers admitted they had begun examining new orbital discoveries for the same peculiar symmetry, a geometry that might suggest intent concealed within motion. Now, 3 Atlas curves towards its outbound trajectory, still concealed behind the sun. Telescopes await the precise moment it clears the glare. For now, it exists not as an image, but as an idea, a void filled with speculation. But even absence can convey meaning. Within that absence, Loeb perceives something that sounds less like secrecy and more like restraint. The quiet etiquette of an intelligence that values distance over direct interaction. Perhaps this is the nature of awareness when stretched across light years. Patient silence and the art of remaining unseen. Every interstellar wanderer we have ever known has followed a similar rhythm: arrival, passage, departure. They trace open arcs across the solar system, leaving brief signatures of motion, and then they vanish into the darkness. But a third hypothesis surrounding 3 Atlas dares to challenge this established pattern. What if this particular object intends to remain? It began as a casual inquiry during one of Avi Loeb's late-night discussions. Yet, the underlying mathematics carried significant weight. Simulations indicate that as 3 Atlas sweeps past the outer planets, it brushes the periphery of Jupiter's immense gravitational field. And Jupiter, with its colossal and patient gravitational pull, possesses the capacity to rewrite trajectories. When approached at a precise angle and velocity, a celestial body can execute a gravity assist maneuver, a cosmic exchange of gravitational force for increased speed. Space agencies utilize this slingshot effect to propel their probes between worlds. However, reversing this maneuver allows gravity to act as a brake rather than an accelerator. It can decelerate a traveler, capture it, and bind it into orbit around the sun. For 3 Atlas, the geometric configuration makes this idea remarkably plausible. Its trajectory passes sufficiently close to Jupiter's influence that a velocity change of less than 1% could trap it here, transforming a fleeting visit into a permanent residency. A subtle push, a hint of impetus, could anchor it amongst the planets for an age. Dr. Lowe termed this the dormant probe hypothesis. Perhaps this visitor arrived not to journey through, but to reside, establishing a protracted, unhurried trajectory from which it might observe the inner celestial bodies at its convenience. Skeptics retort that the predictable laws of celestial motion require no motivations. Comets frequently brush past Jupiter each year and depart altered. However, none have done so with such unwavering consistency, such profound quietude, such an obstinate refusal to comport itself as mere cosmic detritus. Its velocity fluctuates with an unnerving smoothness. Its rotation remains steadfast, as if unseen adjustments perpetually maintain its equilibrium. It progresses, according to Dr. Lowe, like an entity navigating through unseen waypoints accessible only to itself. Within scientific discourse, conjecture circulates with caution. Certain researchers envision a manufactured probe, self-directed through infinitesimal shifts of internal mass or faint expulsions of gas, microthrusters concealed beneath the clamor of solar radiation. Others entertain grander, more enigmatic notions, an autonomous construct destined to drift for millennia after its creator's demise, still adhering to directives predating our very species. In the grand tapestry of cosmic time, the realms of poetry and physics occasionally converge into a single idiom. And should it persist, what then? The possible outcomes range from serene to profoundly alarming. It might be a silent observer, meticulously documenting Earth's electromagnetic signature, charting magnetic fields, cataloging atmospheric compositions, and detecting the subtle hum of our civilization. Alternatively, it could be a derelict vessel, a spectral machine endlessly looping through solar light, its original purpose lost to time. A relic from a civilization that vanished before humanity even conceived of naming the stars. Dr. Lowe consistently commenced his lectures in the same manner, his voice pitched low enough to command the room's absolute stillness. He would remind his audience that the absence of evidence is not, in itself, evidence of absence. For a fleeting instant, the divide between scientific inquiry and fervent belief dissolves. Equations recede into silence. After all, curiosity is the one implement that never succumbs to rust. The very notion of an interstellar traveler electing to linger irrevocably alters our most deeply ingrained assumption that we are alone. It suggests a continuity where we previously perceived isolation, a cosmic architecture of intellects dispersed across vast interstellar distances, yet unified in their shared sense of wonder. If the three-eye atlas were to elect to remain, then we would transcend our role as mere spectators of the universe, becoming instead its custodians. The solar system, for the first time, would transform from an isolated dwelling into a sanctuary. When the boundaries of scientific measurement are reached, imagination takes flight. For the ensuing months, the three-eye atlas will traverse beyond the sun's direct illumination, vanishing into its brilliant glare. No telescope will detect it. No instrument will chart its journey. Only upon its reappearance, diminished and distant, yet still detectable, will we ascertain its decision. Did it retreat back into the interstellar void, or did it decelerate, settling peacefully into an orbit amongst us? Until that answer emerges, the collected data terminates mid-statement, and the narrative awaits its continuation. Yet, the human intellect finds it difficult to wait passively. In the interstitial space between analysis and profound awe, another form of gravitational pull begins to exert its force, the weight of existential questioning. If the three-eye atlas were to tarry, does it linger to observe, to comprehend, or to await something? That singular query redirects the trajectory of science toward the realm of myth, drawing us away from predictable paths and mathematical computations into something far more ancient: intent. For beyond the principles of physics lies apprehension, and beyond the calculations of probability lies purpose. And beyond purpose, perhaps a more somber design, one that thinkers have alluded to for decades, a hushed hypothesis of cosmic perpetuation. They refer to it as the dark forest. Within this conceptualization, the universe is not a dialogue, but a profound silence. Civilizations scattered amongst the stars remain concealed, because any manifestation of their presence constitutes an inherent risk. To expose oneself is to broadcast one's location within a wilderness where any eavesdropper might also be a hunter. Silence thus becomes a form of camouflage. Patience transforms into a defensive stratagem. Consequently, our collective gaze turns inward, imbued with a sense of disquiet. Perhaps the three-eye atlas is nothing more than inert rock and silence, yet perhaps its restraint, its meticulous precision, its deliberate avoidance of luminescence are not accidental occurrences at all. Perhaps they are ingrained habits cultivated in a more primal sky, where survival depended not on being observed, but on remaining unseen. For centuries, we have strained to detect voices amongst the stars, anticipating cordial greetings, expecting beacons of light. However, the more intently we search, the more the pervasive silence begins to feel intentional. It is conceivable that the watchers are already present. Perhaps they have always been here, concealed in the same brilliant shroud of the sun that we might now aspire to utilize. As the contemplation of awaiting an advanced intelligence began to take root, another striking correspondence revealed itself, one that spanned not across physical space, but through the dimension of time. Long before the advent of our telescopes, preceding radio waves, satellites, and the incessant hum of electricity, the nocturnal sky above Earth was remarkably tranquil. 8,000 years prior, only the flickering glow of firelight from villages illuminated the banks of the Nile, the Tigris, the Indus, and the Yellow River. Humanity was in its nascent stages of settlement, cultivation, and calculation. Clay tablets bore the imprints of symbols. Fabrics were adorned with intricate patterns. The first cities began to erect their ramparts against the encroaching winds. These represented the initial tentative steps of civilization, the inaugural endeavors to solidify memory, to imbue thought with a form perceivable and enduring. According to established orbital models, this same epoch marks a secondary, obscured genesis. Approximately at the juncture when humans acquired the art of writing, the celestial body Three-Eye Atlas was traversing the outermost boundaries of our solar system, the Oort cloud. This vast halo of ice and dust is where the sun's gravitational influence gradually dissipates into the profound emptiness of interstellar night. It would have entered this region long before the conception of telescopes, drifting inward, undetected, for 8 millennia. While humankind was inscribing laws and myths onto stone, an entity originating from another star was already embarking on its slow descent toward them. Dr. Loeb acknowledges this parallelism without asserting inherent purpose. Nevertheless, it persists as a coincidence too aesthetically refined to dismiss. If the Three-Eye Atlas carries a mission of observation, of data collection, through a patient drift across the cosmic darkness, then its temporal progression mirrors our own developmental ascent. The era of written language, the rise and subsequent decline of empires, the very shaping of continents by human hands, all of this could have transpired beneath its silent passage. Every narrative we have constructed concerning the heavens may have been articulated under the shadow of its journey. The Oort cloud itself serves as a kind of cosmic demarcation zone, a trillion frozen remnants tracing orbits in the twilight region between our sun and the abyss. To traverse it demands neither accelerated velocity nor fortunate circumstance, but rather intention, or something that strongly resembles it. A traveler entering that expanse 8,000 years ago would have been loosely bound to the sun, tracing slow, circuitous paths through the void, before eventually falling inward, much like a profound thought that takes centuries to coalesce before finding vocal expression. Ancient inscriptions speak of luminous phenomena that appeared and vanished. The Sumerians chronicled celestial wanderers that resembled flames. The Egyptians documented messengers radiating brilliance without trailing any visible tail. These might be considered mere coincidences, yet their echoes resonate persistently, hints that we have perpetually gazed skyward, sensing profound significance in the movements observed. If the three-eye atlas commenced its descent precisely as we began our own ascent, then the parallel becomes deeply unsettling. Civilizations flourish, decay, and ultimately fade into obscurity. Yet, an interstellar traveler, whether composed of rock or imbued with sentience, possesses the capacity to endure beyond them all. Its 8,000-year voyage has witnessed the inception of writing, the collapse of empires, and the meticulous charting of the heavens by the ancient Greeks. And now, as our telescopes finally capture its faint reflection, we comprehend that it has been present all along, patiently, unannounced, traversing the very sky that once cradled humanity's earliest supplications. Perhaps it is mere coincidence, or perhaps the chronicle of civilization has not solely been inscribed on Earth. Conceivably, this represents the most authentic symmetry of all. While we endeavor to comprehend the universe through articulation, we simultaneously learn the profound importance of silence. For 8,000 years, we have permeated the darkness with words, equations, radio transmissions, and fervent prayers. And now, as a solitary interstellar traveler quietly glides past our sun, we begin to grasp that silence too can signify deliberate intent. Within the lexicon of cosmic philosophy, silence is not an absence, but a strategic maneuver. This concept originates from Lucian's haunting vision and the perplexing query posed by Enrico Fermi decades ago. Where is everybody? A galaxy teeming with hundreds of billions of stars should logically be abuzz with a multitude of voices. Based on sheer probability alone, intelligent life should have emerged countless times. Yet, the celestial expanse remains profoundly mute. No signals pierce the cosmic static, no alien metropolises gleam against the starlight, no transmissions disrupt the pervasive hush. The apparent emptiness feels deliberate, the quietude of something acutely aware of the risks associated with announcing its presence. The dark forest hypothesis offers a stark yet elegant explanation. The universe is not barren due to the rarity of life. Rather, it is silent because life exercises extreme caution. Envision a vast nocturnal forest. Each civilization represents a hunter, moving stealthily amongst the trees, listening for the faintest rustle. To reveal one's presence, to emit a loud cry, to ignite a fire, is to court discovery by a more formidable entity. The sole imperative is survival through restraint. Speak, and you risk annihilation before your words even fade. Dr. Loeb, ever the scientist, rarely ventures into philosophical discourse, yet the proximity of the three-eye atlas compels him towards it. If its trajectory and timing are deliberate, then its quietude might not stem from curiosity, but from apprehension. A species capable of interstellar transit would intrinsically understand that the paramount peril lies in visibility. It is plausible that the atlas is not here to engage with us, but merely to observe, its silence a form of self-preservation. This contemplation offers more disquiet than solace, for if they are observing us, they are already cognizant of the dark forest's implicit rules, and we are the ones broadcasting our presence loudly. Our radar, our deep space transmissions, our incessant digital chatter propagate outward at the speed of light. A luminous shell of human activity expands through the galaxy. For a millennium to come, these broadcasts will continue their outward journey, announcing our existence to any entity patient enough to receive them. Within scientific communities, a subtle anxiety is beginning to stir. The ongoing debate centers on messaging extraterrestrial intelligence. Should we continue to transmit signals into a cosmos that might prefer silence, especially if other civilizations choose to remain hidden? Perhaps we too should adopt a similar strategy. Yet, the innate human compulsion to communicate is deeply ingrained. To remain silent would be to concede to a universe devoid of dialogue, a sky populated by silent observers who never respond. The dark forest theory is not a definitive judgment, but rather a mirror. It reflects our own inherent instincts, our fears, our propensity for violence, and our deep-seated longing for survival, projected onto the vast canvas of the stars. It is possible that the danger does not reside in alien malevolence, but in the assumption that they would think as we do. Nevertheless, the logic possesses a certain elegance. When life is inherently fragile, discretion evolves into wisdom. And thus, the forest remains cloaked in darkness. Each world drifts behind its veil of quietude, its civilizations aging in isolation, their histories unfolding unseen. Perhaps amongst them, the traveler known as Atlas moves with deliberate subtlety through the arboreal expanse, gathering hushed observations rather than issuing pronouncements, not as an invader, nor as a herald, but simply as another cautious wanderer attempting to avoid being the first to break the pervasive silence. If this premise holds true, then the mere act of observing it might already constitute a transgression of this fundamental rule. For within the established laws of the dark forest, awareness itself is inherently perilous, and somewhere within that boundless silence, it is conceivable that something has just cast its gaze back upon us. If an entity within that dark forest has indeed reciprocated our observation, the most unsettling aspect would not be inherent malice, but rather rational calculation. For the more deeply one delves into the logic of the dark forest, the more evident its underlying principles become. Its governing law is not cruelty, but an inexorable inevitability. Every sentient world, regardless of its inherent nobility or benevolent disposition, confronts the same insurmountable conundrum. How can one ever be absolutely certain that another intelligent entity concealed within the darkness will not initiate an act of destruction first? It commences, as so many terrifying scenarios do, with a simple thought experiment. Imagine yourself standing alone in a forest under the cloak of night. You are unable to ascertain the presence of others, yet you are aware of their existence. You are ignorant of their nature, their intentions, or their fears. You cannot speak without revealing your precise location. Consequently, you draw slow, measured breaths, your weapon held ready, understanding that silence might represent the sole pathway to survival. Now, extrapolate that scenario across the vastness of the galaxy. Distances are measured in light years, communications require centuries to elicit a response, and signals may persist long after the civilizations that generated them have ceased to exist. Under such conditions, even a gesture of greeting can be misconstrued as an act of aggression. A probe dispatched with peaceful intentions might be perceived as an imminent threat. Every moment of delay exacerbates misunderstanding until apprehension transforms into a matter of cold, hard mathematics. Dr. Loeb refers to this as the paradox of intelligence. The more sophisticated a civilization becomes, he once articulated, the greater its inherent capacity for fear. The identical capability that facilitates the construction of conduits between stars can also result in the annihilation of whatever lies beyond them. Power and dread are inextricably linked twins. As one grows, the other intensifies. If the three-eye atlas possesses advanced technological capabilities, its silent passage might signify a predetermined choice to observe rather than to communicate. This would position it as a survivor within a universe populated by predators, an emissary from a civilization that long ago comprehended the substantial cost of attracting attention. Its journey through the solar system, steady, unchanging, and distant, resembles the flight pattern of an entity adept at remaining unseen. It makes no move to approach Earth. It emits no flares, no blinking signals. Silence serves as its protective armor, but silence can also function as a reconnaissance tool. There exists an alternative, more ominous interpretation. The atlas might not be the observer, but rather the instrument of observation itself, a mechanism designed to measure, to record, and perhaps to prepare. In a cosmos where every encounter carries the potential for fatal consequences, even peaceful entities might opt for preemptive measures, dispatching probes in advance of outward expansion, cataloging potential threats, and mapping worlds that might one day become rivals. Viewed through this perspective, the atlas transforms into a scout drone, a sentinel circling a potential battlefield long before the initial engagement. And yet, if one reverses the perspective, the reflection inevitably turns upon ourselves. Voyager, Pioneer, New Horizons, our own emissaries traverse the interstellar void, broadcasting music, navigational coordinates, and maps. Each vessel carries our identity meticulously inscribed onto metal. To another intelligence, we might already appear as the very predators we fear. This mirroring symmetry is precisely what renders the theory so profoundly unsettling. There are no inherent monsters here, only caution, only logic. Every world navigates through a shared, silent dread, yearning for continued existence while simultaneously terrified of being discovered. The predator's dilemma elucidates the profound stillness that ensues upon awareness. Once two civilizations acknowledge each other's presence, equilibrium dissolves. To act first invites a retaliatory overreaction. To delay action courts potential extinction. Game theorists refer to this as a zero-sum communication deadlock, a critical juncture where wisdom and terror become indistinguishable, and even inaction becomes a calculated strategy. For Dr. Loeb, this realization transforms the three-eye atlas from a mere anomaly into a profound mirror. He writes that it is not an alien enigma, but rather a manifestation of what intelligence embodies when survival itself becomes precarious. Its composure, its meticulous precision, its unwavering commitment to silence are not the gestures of idle curiosity, but rather of fear meticulously engineered into purposeful motion. Now, as telescopes capture the faintest glimmer of its receding light, the fundamental question circles back to us. If we, like ancient beings, were adrift alone in a perilous sky, would we conduct ourselves any differently? Would we broadcast our presence, or would we too seek refuge amongst the stars, straining to discern the slightest exhalation that might signal the proximity of another hunter? The forest remains steeped in silence. We are simultaneously hunters and prey, transmitting our existence into the vast darkness while fervently hoping that no entity close enough to perceive us decides to respond, and somewhere beyond the orbital path of Jupiter, an object approximately 6 miles in diameter glides silently between planets, a steady and wordless testament to the possibility that perhaps someone already has. Perhaps that is the subtle irony underlying all our persistent searching. In our endeavor to comprehend the visitor, we have ultimately turned our focus inward, studying ourselves. Across the vast expanse of millennia, the heavens have consistently served as a reflective surface for both our deepest fears and our most ardent desires. Each civilization in every epoch has gazed upward and perceived its own likeness shimmering amongst the stellar expanse. The ancient Sumerians etched omens into clay whenever comets dramatically streaked across the celestial canvas. The Greeks meticulously constructed constellations, weaving them into myths and transforming wandering points of light into narratives of gods and profound longing. During the Renaissance, astronomers meticulously directed their lenses toward the sky, discovering not definitive answers, but rather older, more profound questions lurking behind newly acquired knowledge. In every era, we have mistakenly identified our own reflection as the true visage of the universe. And perhaps that has always been the fundamental purpose. Now, we gaze once more, our vision augmented by orbiting metallic instruments through telescopes positioned above the Earth's atmosphere. We encounter another wanderer from the darkness, the three-eye Atlas, and once again, we imbue its silence with narratives. This is precisely what humanity does when confronted with the unknown. We narrate the void, rendering it less overwhelmingly infinite. From his office at Harvard, Dr. Loeb once remarked, "Every discovery is an echo from the past, a sound that required light years to reach us." It is possible that the echo we perceive in the Atlas's trajectory is not a distinct voice calling out from afar, but rather our own voice reverberating back from the profound depths. The concept of the dark forest may describe less about the inherent motivations of extraterrestrial intellects and more about the underlying architecture of human apprehension. We perceive the universe as a grand stage, upon which we project both our fervent hope for connection and our deeply ingrained instinct for caution. However, perhaps silence carries a more gentle connotation. It is conceivable that we are neither disregarded nor pursued, nor are we truly alone. Perhaps the chasm separating civilizations is not defined by apprehension, but by sheer immensity. Across 10,000 light years, even the most powerful transmission gradually attenuates into a mere whisper. Communication across such an unfathomable expanse might bear a closer resemblance to prayer than to a conventional dialogue, a message released into the void with no assurance of a response. It is plausible that this is precisely what the Atlas represents, a fragment of another civilization's silent petition, drifting, whether by chance or by deliberate design, through our cosmic neighborhood, never intended for our discovery, yet found all the same. And still, the remarkable symmetry refuses to dissipate. 8,000 years ago, humanity began to communicate through symbolic representations. Within that identical grand narrative, the Atlas entered the sun's gravitational domain. Our timelines intersect like two distinct notes within a single chord, struck at vastly different moments in history, yet resonating harmoniously together. It is possible this is mere coincidence, yet perhaps this is the inherent nature of intelligence when faced with insurmountable distances, forging connections not through language, but through patterns. Every image we capture is, by its very nature, historical. The light emanating from the Atlas reaches us mere minutes after its departure. The starlight from beyond it takes years to traverse the intervening space. The galaxies situated behind those stars require millions of years. To gaze outward is invariably to gaze backward, to perceive the past shining faintly through the present moment. Thus, we stand here beneath a sky that listens far more than it speaks, apprehending echoes that predate our very species. They do not offer verbal responses. They do not need to. Their profound silence serves as a potent reminder that the act of questioning is, in itself a form of evidence that to wonder is intrinsically to exist. And as the three-eye atlas once more glides into the profound darkness, leaving behind only faint traces within our data and our imaginations, we remain below, our eyes perpetually turned upward, our hearts tilted toward the infinite, waiting, as we always have, for the next echo to arrive. And as the three-eye atlas drifted beyond the sun's blinding glare, its diminishing echo dissolving into mere data and conjecture, another memory resurfaced from the archives of our sky. For before this current visitor startled the world, there had been another, smaller, quieter, and equally improbable. It was October of the year 2017, and the telescopes at the Pan-STARRS Observatory in Hawaii detected a fleeting flicker of light moving at a velocity far exceeding that which would be expected for an object originating within our solar system. Its trajectory betrayed its origin immediately. Not a circular path, not a recurring loop, but merely a transient passage through space. A stranger journeying through our celestial vicinity, seemingly unaffected by the sun's gravitational pull. It was named Oumuamua, a Hawaiian term signifying a messenger from a distant land, arriving for the first time. The name carried an aura of both reverence and underlying unease, as if humanity had just received a brief missive from another star. The data poured in, and each piece of information contradicted prevailing expectations. Oumuamua measured only approximately 400 feet in length, yet its brightness fluctuated erratically, suggesting it was an elongated object tumbling like a slow spinning coin. Initially, astronomers classified it as a comet. However, comets exhibit characteristic venting of gases and the shedding of tails when exposed to warmth. Oumuamua exhaled nothing. Its spectral analysis revealed no traces of water, carbon dioxide, or dust, only the reflection of sunlight off a surface that gleamed with the appearance of metal or exceptionally dense rock, presenting a clean and silent profile. Then came the truly astonishing aspect. As it receded from the sun, it began to accelerate. The increase was subtle, yet measurable. Gravitational forces alone could not account for this phenomenon. Something had propelled it forward, yet no jets, no emissions, and no debris were detected, only forward motion without any discernible cause. For weeks, instruments trained on its diminishing glow as it receded, twirling into the void. Artists attempted to visualize it, a fragment, a cylinder, a flat plane, even a sail. Each depiction became an admission, humanity's endeavor to give form to what our technology could barely grasp. Some scholars posited it was a piece of a planet shattered eons ago, ejected from a distant star system. Others mused about deliberate construction, an ancient, minimalist vessel that had outlived its creators. Amidst these theories, one voice resonated with particular clarity. Cautious, yet unhesitating, he proclaimed Oumuamua the first extraterrestrial visitor ever detected by humankind, and possibly the initial manufactured object. This declaration split the scientific community. Some saw boldness, others foresight. Could a civilization predating ours have engineered something so minute, so precise, that it traversed the galaxy long after its makers had turned to dust? Within a month, Oumuamua had vanished from our sight, shrinking to a mere point of light, then fading into recollection. Yet, it left behind an enduring enigma. If that was the inaugural harbinger, what tidings had it conveyed? And if Three-Eye Atlas represents the second, larger, slower, more methodical, then perhaps the query shifts from identifying the sender to understanding the discourse already underway between celestial bodies and why we are only now learning to decipher it. Even as 3 Atlas ignites new questions from the farthest reaches of our solar system, the puzzle of its precursor still looms, unresolved, echoing through years of accumulated observations. For before this immense traveler blazed through our celestial sphere, there was Oumuamua, diminutive and silent, the inaugural messenger to navigate the spaces between planets, leaving us to ponder the origin of its journey. As it traversed the inner solar system, astronomers anticipated its movement would align with the predictability of celestial mechanics, the elegant mathematical framework governing all orbital bodies. However, as the observational data grew, a subtle yet extraordinary anomaly emerged. After completing its solar orbit, Oumuamua began to accelerate beyond the dictates of gravity. This acceleration was minute, merely a few 10,000ths of a meter per second squared, yet it persisted with unwavering consistency, like a faint whisper within the calculations. No recognized model of atmospheric drag or gravitational influence could account for it. It was as though an unseen force had gently nudged the object, setting it adrift. Initially, the teams at ESO and NASA's Jet Propulsion Laboratory suspected instrumental error, perhaps a miscalibration, a reflection anomaly, or a measurement bias. Nevertheless, the readings held firm, corroborated by observatories worldwide. The phenomenon was undeniable. Comets occasionally exhibit similar behavior, with solar heat vaporizing their icy surfaces, creating miniature jets that propel them forward. However, in this instance, there were no visible jets, no dust, no surrounding halo. Oumuamua remained inert, seemingly metallic in its reflectivity, entirely unaffected by the sun's warmth. The paradox intensified. It was either a comet, unlike any ever observed, or something else entirely. Even its acceleration possessed a peculiar orientation, not random, but aligned almost perfectly away from the sun, as if light itself were exerting pressure. This observation captured Avi's attention. He proposed a hypothesis, both elegant and daring, that Oumuamua might be a solar sail, a wafer-thin structure designed to harness the pressure of solar radiation for propulsion. He calculated that if its material were less than a millimeter thick, the figures aligned precisely. Such a construct could indeed drift through interstellar space for millennia, powered solely by stellar light. To some, it sounded like pure fantasy, but the mathematical foundation was solid. And if the mathematics holds true, the universe must at least permit such a possibility. Skeptics countered with alternative theories. It could be a fragment of frozen nitrogen from a disintegrated exoplanet, or sublimating hydrogen frost, or some exotic material yet undiscovered. Each proposed model explained a facet of the enigma, but contradicted another. None encompassed all the evidence. The object, already receding into darkness, could no longer provide further answers. Ultimately, the acceleration of Oumuamua remained an inexplicable tear in the predictable fabric of celestial law, a minuscule deviation hinting at a vast, underlying uncertainty. For scientists, this presented both frustration and fascination, a solitary anomaly suggesting a profounder pattern, a message that vanished before it could be deciphered. It arrived and departed in silence, leaving behind only a subtle curve in the observational record, a trace of its movement, and a question too immense for our instruments to fully comprehend. What force, whether natural or otherwise, reached across the expanse of light to impart that final, gentle impetus toward the stars? And in that quiet aftermath, after the equations had been rigorously tested and the numbers stubbornly refused to conform, the impossible began to seem almost plausible. The object had accelerated when no discernible force should have acted upon it. It had remained dry when every comet emanates vapor. It had reflected light like metal, yet possessed negligible mass. Consequently, one idea inevitably surfaced from the silence. It began, as most paradigm shifts do, with hesitation. When Avi first suggested that Oumuamua might be propelled by light itself, his colleagues initially smiled, then furrowed their brows. The concept of a light sail, a structure so delicate that the pressure of photons could propel it across the vast interstellar distances, belonged to the realm of science fiction, not rigorous astrophysics. However, the data refused to conform to conventional explanations. Something was imparting a consistent, non-gravitational acceleration to the object, and the sole candidate that matched both the direction and magnitude of this force was sunlight itself. In Lowe's model, Oumuamua could have been a wafer less than a millimeter thick, lighter than a sheet of paper, its surface area thousands of times greater than its mass. Under such conditions, even the subtle pressure of solar radiation would have been sufficient to move it precisely as the observations indicated. If its surface were a highly reflective, mirror-smooth metallic material, it could account for the dramatic fluctuations in brightness as it tumbled, each rotation sending a brief glint through the darkness, akin to a coded signal. What was initially interpreted as an asteroid, Lowe suggested, might instead be a fragment of advanced technology, a device that traveled without conventional fuel, guided solely by light. And the most astonishing aspect was that humanity already possessed the foundational principles. Projects such as Chaos in 2010 and LightSail 2 in 2019 had demonstrated photon-driven propulsion on a miniature scale. The underlying principle was sound, though the engineering remained rudimentary. Now, imagine a civilization 1,000,000 years more advanced, refining the same principle into an art form, crafting sails that navigate between stellar systems like silver seeds, carried by the pressure of starlight. The concept felt both audacious and remarkably conservative. It necessitated no new physical laws, only a more ancient and sophisticated level of craftsmanship. Skeptics naturally raised objections. They proposed that Oumuamua was a chip of frozen nitrogen or a shard of hydrogen ice, sublimating invisibly and generating just enough thrust to mimic propulsion. Yet, each of these naturalistic explanations demanded near impossible conditions, so delicate and improbable that Lowe's artificial sail began to appear as the most straightforward explanation in a universe that often conceals profound simplicity behind awe-inspiring phenomena. When all other probabilities were exhausted, the improbable began to sound logical. His research paper ignited a fierce debate. Some accused him of romanticizing the data, of pursuing fiction through complex calculations. Others more quietly acknowledged the disquiet that had permeated their observations. The acceleration was real, the silence of conventional explanation undeniable. If it behaves like a sail, Lowe argued, then we must at least consider the possibility that it is one. Beyond the academic dispute, the imagery captured the public imagination. Newspapers featured artistic interpretations of a gleaming shard gliding between planets. Artists depicted it as a messenger, an ancient relic, a solitary survivor of a vanished civilization, or perhaps a probe still receiving commands from a long-deceased star. For a brief moment, the world collectively looked upward, experiencing a resurgence of ancient wonder, a sense that the stars might still be sending missives, and that we had just begun to learn how to read them. As Oumuamua receded into the vastness, its light too faint, its signal lost, the narrative it left behind transcended physics, venturing into philosophy. For if a light sail could endure the immense distances between stars, then its construction represented an act of faith, faith that someday, somewhere, someone would notice. Perhaps it was never intended for us. Perhaps we were merely standing within the path of an experiment older than our species. The sail theory remains unverified, neither myth nor certainty, suspended like the object itself between the measurable and the miraculous. A faint glimmer of engineered light traversing the night, whispering the most fundamental of cosmic truths. That intelligence, wherever it may arise, learns not only to harness energy, but also to perceive the light. The image of that delicate sail, glinting once in the sunlight of our star before vanishing, did not fade with distance. It remained etched in our collective consciousness, a question cloaked as an object. For when Uma disappeared into the outer darkness, it left behind not a resolution, but a silhouette, a form of intent traced against the void. The available data was sparse, the background noise persistent. Yet, one pattern consistently emerged. A small, silent entity entered the solar system, accelerated without apparent propulsion, and departed on a trajectory that skirted our orbit as if by design. To Avi, this sequence resonated with the methodical approach of reconnaissance. He termed it the scout hypothesis. In his view, Umuam might have been a probe, not necessarily the first to arrive, but the first we were capable of observing. Its dimensions were modest, barely 120 meters, too small for most telescopes to detect. Its reflectivity was higher than that of a rocket, yet too low for typical metal, suggesting a construction prioritizing endurance and efficiency over mass. If a civilization aimed to dispatch instruments across interstellar distances, this would be an optimal approach. Small enough to remain undetected, robust enough to withstand eons, and silent enough to go unnoticed. A scout, rather than a full vessel. Lowe's reasoning extended beyond mere astronomical observation. It was anthropological. Human explorers, too, dispatched scouts first. Small craft to survey terrain, sensors to analyze atmospheric conditions, drones to glimpse the unknown. They gathered intelligence, reported, and withdrew. Umam's passage felt analogous to this, a swift, cautious flyby, a fleeting observation rather than a formal greeting. And when, years later, the second interstellar object appeared, 3I Atlas, immense, luminous, and deliberate, it seemed to fit the subsequent stage of the same logical progression. Perhaps this was the established pattern. A scout followed by a secondary arrival, larger and slower, engineered to examine what the initial scout had discovered. The concept was bold, even cinematic, and most of Lowe's colleagues reacted with apprehension. They dismissed it as narrative speculation, not scientific inquiry. Yet, even they conceded the unsettling nature of the coincidence. 2 interstellar visitors in less than a decade, following billions of years of silence, represented an improbable statistical anomaly. Either we are extraordinarily fortunate, Lowe stated softly, or someone is paying attention. In his speculative framework, he envisioned a network of autonomous probes, machines designed to roam the galaxy for millennia, propelled by light sails or magnetic fields, each carrying directives to observe and record. These probes would not require a return journey. Their creators might have long since perished, but their legacy would persist, drifting from star to star like seeds carried on the cosmic wind. They would serve as archaeological messengers from civilizations that refuse to vanish entirely. Some would inevitably fail, while others would remain dormant, awaiting the next sufficiently bright light to reawaken them. If Umeammua was such an artifact, then its passage was not random. It represented the convergence of 2 timelines, one measured in centuries, the other in eons. A rendezvous lasting mere weeks, yet spanning cosmic history. The symmetry becomes more profound when juxtaposed with 3 Atlas. If Oumuamua served as the scout, could Atlas represent the follow-up? A craft returning along a nearly identical trajectory, vastly larger, arriving not by chance, but according to a predetermined schedule. First a whisper, then a torrent. It is the kind of sequence found in the most ancient narratives. Reconnaissance followed by revelation. Someone observing, then someone drawing closer. Lo, ever the scientist, tempers wonder with caution. We must maintain skepticism, he advises, but skepticism must never harden into an unwillingness to see. Certainty, after all, is as perilous as blind faith. It prevents us from perceiving what may still lie hidden within the data. In those spaces where observation ceases and imagination takes flight, our instruments falter, but curiosity continues the work, and thus, the narrative remains incomplete. Oumuamua continues its outward journey, while 3 Atlas moves inward. Their trajectories intersect like 2 lines of script scrawled across the solar system, messages dispatched from opposing directions. Their meaning remains uncertain, yet their presence is undeniable. Whether etched by nature or by intelligence, the message conveys a similar sentiment. Even if the universe appears silent, it is never static. Yet, even as the 2 trajectories, Oumuamua outbound, 3 Atlas inbound, seem to sketch a message across the solar system, the ensuing echo was not one of wonder, but of caution. Every profound mystery in science inevitably encounters its counterpoint: skepticism. As the initial analyses reached the public, sparking discussions in newspapers, press conferences, and hushed theories about alien spacecraft, the fascination that had captivated the world began to recede, replaced by calculation. The astronomical community, shaped by centuries of scientific restraint, commenced articulating their findings in the language of control and probability. Their refrain was consistent and familiar, not alien, merely unusual. At the Center for Astrophysics in Cambridge, researchers meticulously re-examined the very data that had ignited such widespread imagination. They observed the same numbers, the same peculiar curves, the same improbable alignments, and they acknowledged them with nods, but did not succumb to impulsive conclusions. Yes, they stated, the trajectories are indeed peculiar, but the cosmos itself is a generator of peculiarities. When one observes billions of objects over billions of years, the improbable becomes an inevitability. Coincidence, given sufficient time, becomes destiny. To them, the arrival of 3 Atlas was not a revelation, but a continuation. The second in an increasingly significant lineage of interstellar wanderers. After all, 2 interstellar objects, Boris and Oumuamua, discovered in 2019 and 2017 respectively, had already demonstrated that comets can traverse the vast distances between stars. Why then should Atlas be any different? Why invoke extraterrestrial technology when ice and rock could provide a perfectly adequate explanation? The fundamental principle of science dictates conservatism. When natural explanations exist, even improbable ones, they must be thoroughly explored before allowing imagination to take precedence. Images captured by NASA's Hubble Space Telescope and terrestrial observatories seem to lend credence to this viewpoint. A faint coma, a shroud of dust and gas, was discernible faintly enshrouding Atlas's nucleus. This, the skeptics contended, was sufficient evidence. A comet, not a manufactured craft. A veil of evaporation, not a cloak of stealth. To them, the question was settled. They pointed out that Atlas's albedo, its reflective brightness, was consistent with fresh ice, not polished metal. Its estimated size, between 6 and 9 miles in diameter, while striking, was hardly unprecedented. The colossal comet Hale-Bopp, which graced our skies in 1997, measured more than 40 miles across. Atlas was indeed vast, but not beyond the realm of natural phenomena. Even its interstellar origin, initially so shocking, now seemed almost commonplace. A single data point in the gradual accumulation of evidence suggesting that the space between stars is not empty, but merely uncharted. And yet, beneath the veneer of caution, a subtler unease lingered. Even the most skeptical researchers struggled to fully account for the precision of Atlas's trajectory, its near-perfect inbound path, and the uncanny alignment that placed the Sun directly between Earth and the object at its closest approach. Perhaps it was mere coincidence, perhaps not. In the subsequent scholarly publications, the tone remained polite but guarded. Extraordinary claims require extraordinary evidence, they reiterated, invoking Carl Sagan's famous dictum. Science, after all, must prioritize factual truth over dazzling speculation. The universe already abounds with enough wonder. It does not require our embellishments to shine brighter. But in the quiet corridors of those same observatories, in the unrecorded hours when the glow of data screens dims and the night settles in, a question persisted. If Atlas is a natural phenomenon, why does nature behave as if it possesses memory? Why does its geometry seem to whisper of intention, its silence mimic restraint? The skeptics successfully restored a sense of balance to the discourse, pulling it back from the precipice of myth. Yet, in doing so, they illuminated a fundamental paradox that shadows all scientific discovery. That even when science appears to close a question, wonder invariably opens another in its wake. And so, suspended between probability and imagination, between the mundane truth and the dazzling unknown, 3 Atlas continues its silent glide, neither definitively proven nor dismissed, its meaning held in that narrow space where certainty ends and curiosity begins. Even as the scientific debate subsided into data tables and conference abstracts, the cosmos refused to remain silent. For when the first deep space images of 3I Atlas were finally transmitted, they shimmered with something achingly familiar, a soft haze encircling a solid core. In astronomy, this indistinct blur has a name, a coma, the telltale sign of an icy body awakening under the sun's warmth. For the skeptics, this was the moment of vindication. A manufactured craft would not sublimate. A comet, however, would. The Hubble Space Telescope, along with instruments situated in Chile and Hawaii, corroborated this assessment. A faint exhalation of vapor was detected, a slow shedding of volatile materials, water, carbon dioxide, and minute particles reflecting light like frost on glass. Spectral analyses revealed characteristic fingerprints matching simpler explanations, indistinguishable from those found in long-period comets originating from the Oort cloud. Even its albedo, its reflective brightness, spoke of clean frost rather than engineered metal. From these clues, a narrative formed, almost too neat to resist. Atlas, the skeptics argued, was not an alien artifact, but a colossal interstellar comet, a relic from another star system that had drifted through the frigid void for millions of years before entering our solar system's embrace. The calculation supported this conclusion. Its diameter of 6 to 9 miles, while substantial, was not unique. The legendary comet Hale-Bopp, which blazed across our skies in 1997, was nearly 5 times larger. In a universe containing trillions of comets, it was statistically inevitable that a few would escape the gravitational pull of their parent stars. Atlas, therefore, was not a miracle, but a predictable outcome. They cited the example of 2I Boris, discovered in 2019, the second known interstellar visitor. Boris behaved precisely like a textbook comet. Its dust tail was bright, its chemistry unremarkable, and its orbit fell within expected parameters. Why, they questioned, must Atlas be different? The cosmos, after all, does not alter its fundamental chemistry for each traveler. Even the object's subtle orbital peculiarities found a terrestrial explanation. As sunlight warmed one hemisphere, jets of vapor could have gently nudged it, subtly altering its velocity. These were fractions too small to perceive directly, but significant enough to be measured. What appeared deliberate might simply be the result of thermal physics, the slow release of ice masquerading as conscious intent. In this light, Atlas was not an alien artifact, but a profound lesson in humility. A frozen relic from another sun, performing its quiet chemical processes beneath our gaze. A stark reminder that nature's simplest mechanisms often appear miraculous when observed from a distance. Even stripped of its mystery, it remained a beautiful anomaly, an exile from another sky, briefly illuminated, then gone. And yet, buried within the data, one persistent anomaly refused to fade entirely. The coma was too faint, the rate of mass loss too low to fully account for the observed acceleration. The equations nearly balanced, but not completely. Something in the data resisted a perfect closure, leaving just enough imperfection to keep both proponents and skeptics engaged. Thus, as Atlas's faint light dimmed against the infinite blackness, the mystery did not vanish. It simply retreated into that ambiguous territory where empirical evidence concludes and imagination takes over. This is the most ancient domain in astronomy, the realm that has always belonged to comets, those luminous contradictions that disappear even as they remind us how thin the line is between scientific understanding and pure wonder. The debate gradually quieted, the data settling into predictable columns. For a brief period, it seemed the enigma might finally dissolve into the mundane. However, the next revelation arrived not with a shock or a spectacle, but with a shift in perspective. For astronomers, scale is the fundamental basis of comprehension. To truly understand an object, one must first grasp its dimensions, the amount of solar radiance it reflected, the strength with which it yielded to Earth's gravitational embrace. And with Thrissa's atlas, these calculations brought immense relief. What had been rumored to be colossal was, by celestial standards, remarkably ordinary. By measuring its luminescence against known comets, researchers estimated its diameter to be between 6 and 9 miles. While vast to us, this size is modest when viewed against the backdrop of the cosmos. The famous comet Hale-Bopp, which graced our skies in 1997, spanned over 40 miles. Even Comet 67P Churyumov-Gerasimenko, visited by the Rosetta probe, possessed cliffs taller than any mountain on Earth. In comparison, Atlas appeared familiar, a significant traveler, but not a giant. Its reflectivity, an albedo near 0.25, told a similar story, shining like ice just beginning to thaw. Spectroscopic analysis revealed a composition mirroring countless frozen celestial bodies: ammonia, carbon dioxide, silicon, and dust, materials forged in the frigid expanses far from alien stars. For planetary scientists, this predictable pattern was almost comforting. Though foreign in origin, its composition was not unique. Its faint bluish hue indicated nothing mysterious, merely fresh frost, not oxidized metallic elements. The variations in its brightness, once thought to suggest deliberate manufactured symmetry, now seemed to be the result of natural unevenness, the way fractured ice tumbles and gleams under sunlight. To the discerning observer, this was clarity. Atlas fit perfectly within the celestial family tree, identified as a comet, not a creation. Its size, its makeup, its rotation, all consistent with countless natural occurrences observed throughout the universe. Yet, even within this conformity, a subtle resonance persisted. It was indeed a comet, but one originating from a distant sun, a different genesis. The water within it had once flowed under a sky we would never witness. Its very atoms were remnants of a lost dawn, transported through the void to cross our path by sheer chance. Perhaps this is the true marvel, not its alien intent, but its familiar form. For a period, the narrative surrounding Atlas seemed to recede, its light dimming, its presence shrinking to mere data entries in archived observatory logs. However, stories encoded in scientific data have a tendency to resurface. By late autumn, the scientific discussion had arrived at a delicate consensus. The evidence strongly supported the comet classification. The mathematical models were precise, and the tone of scientific publications was calm. But beneath this surface composure, a lingering unease persisted, a subtle feeling that Atlas defied easy categorization. The primary issue remained its trajectory. Its path through the orbital planes of the 4 inner planets was unnervingly precise, an incredibly narrow thread of motion woven with uncanny accuracy. Statistically, such an alignment should have been an anomaly, with a probability less than 0.005%. Yet, there it was, a perfect geometric pattern traced across the solar system. Even the most skeptical scientists, usually grounded in probability, found themselves unsettled by the edge of their calculations. Then there was the matter of its timing. At the precise moment Earth would have had its clearest observation window, Atlas slipped behind the sun, disappearing from view for weeks into its blinding glare. This alignment occurred exactly during its closest approach, as if the universe, or something within it, had favored discretion over spectacle. Most attributed it to coincidence, but repeated coincidences can begin to resemble deliberate orchestration. Its coma, too, defied expectations. The surrounding halo of vapor and dust was too faint to account for the subtle acceleration detected during its passage. If gas jets were the driving force, the spectral signature should have been unmistakable. Instead, there was only silence and motion without observable cause, a propulsion without evidence. It did not sputter like a typical comet. It glided as if propelled by an unseen force. These peculiarities did not immediately revive the alien hypothesis, but they certainly prevented its complete dismissal. Avi's ideas continued to surface at the fringes of every discussion, exerting their own subtle gravitational pull. His insistence on remaining open to the extraordinary had become a mirror, reflecting a fundamental, albeit uncomfortable, truth of science. That explanation and mystery are often intertwined, born from the same set of observations. Thus, Atlas remained in its initial state of ambiguity, suspended in that narrow space where numerical data ends and awe begins. It was too natural to be deemed artificial, yet too precisely controlled to be attributed solely to chance. Science had meticulously mapped almost every aspect of its behavior, but not the ultimate reason behind it. And in that small, unexplained residue, curiosity found renewed vigor. As Atlas moved beyond Mars, the telescopes refocused elsewhere, their observational capabilities returning to dormancy. Yet, the central question lingered, a faint echo in the collected data, a whisper across the void, suggesting that the narrative that began with Oumuamua might not have concluded, but merely paused, awaiting the arrival of the next cosmic visitor. In the wake of Atlas's departure, the conversation inevitably circled back to the first interstellar visitor that had profoundly disrupted the established certainty in astronomy. Because before Atlas, there was the enigma that initiated everything: Oumuamua. When Oumuamua first traversed our solar system, it performed a quiet impossibility. It accelerated. This minor deviation challenged the elegant mathematics of celestial mechanics, prompting a flurry of theories, both speculative and cautious, all grappling with the same fundamental question: how can a celestial object increase its speed without discernible engines or exhaust? Out of this confusion, a more plausible explanation began to emerge, one that required no alien spacecraft or solar sails, relying only on the delicate chemistry of frozen celestial bodies. Two planetary scientists, Alan Jackson and Stephen Desch, proposed the nitrogen ice fragment hypothesis. They theorized that Oumuamua was a fragment of a distant planet, akin to Pluto, that had been dislodged by a catastrophic impact eons ago. Imagine a frozen moon shattered by a collision so immense that it launched glaciers into the void, each fragment drifting for millennia through the darkness, pale and silent, until one happened upon our path. Nitrogen ice, they argued, was the ideal candidate. It is lightweight, volatile, and highly reflective. Its lustrous surface could explain the object's bright albedo, and its slow sublimation under sunlight could generate the faint acceleration observed as it departed the inner solar system. A subtle release of nitrogen gas, invisible to our instruments, might have propelled it forward without the telltale debris characteristic of a comet. This theory offered an elegant solution, perhaps too elegant. It restored the comforting predictability of natural law, positioning nature, rather than intelligence, as the grand orchestrator. Under this interpretation, Oumuamua became not a messenger, but a postcard from another solar system, a fragment of an ancient surface delivered by accident. The mathematics even possessed a certain poetic quality. Billions of icy fragments could have been ejected over cosmic time, increasing the likelihood that one might cross our sky once every few generations. However, beauty in science does not equate to proof. For the numbers to align, those distant star systems would need an improbable abundance of Pluto-like worlds, each exceptionally rich in frozen nitrogen. Furthermore, nitrogen ice, being delicate under radiation, should have evaporated long before such a fragment could traverse interstellar distances, unless its journey was remarkably brief. The hypothesis resolved many aspects, but not all. Nevertheless, it offered a rare sense of solace. Unlike the solar sail theory, it posited no intention, no guiding alien hand, merely the interplay of physics, chance, an ancient collision, a protracted journey, and a fleeting encounter with our star. A fragment of another world, slowly turning in the sunlight before receding into shadow. As one explanation waned, another began to solidify, delicate, almost imperceptible, yet driven by the same human desire to anchor the extraordinary within the realm of the natural. If nitrogen ice had been the first comforting theory, hydrogen ice emerged as the second, stranger, more ethereal, but born from the same yearning to keep the extraordinary within nature's purview. Hydrogen, the universe's most fundamental element, the initial product of the Big Bang, the fuel of stars, and the mist between galaxies. However, in extreme cold and under immense pressure, even this simplest element can assume a solid form: ghostly hydrogen ice, transparent, fleeting, and nearly undetectable. In 2020, a team of astrophysicists proposed that Oumuamua might have been composed almost entirely of this rare frozen hydrogen. They envisioned its origin within a vast molecular cloud, one of those colossal stellar nurseries where gravity sculpts matter into nascent stars. Within these clouds, temperatures plummet to levels approaching absolute zero. Hydrogen gas can adhere to dust grains, condensing into crystalline sheets. Over millions of years, Collisions or tidal forces could dislodge these sheets, sending them drifting through the interstellar darkness. The concept's elegance lay in its ephemeral nature. Hydrogen ice, upon warming, leaves no trace. It evaporates without dust, without light, without residue. As Oumuamua approached the sun, its surface might have begun to sublimate, releasing invisible jets of gas that provided just enough thrust to explain its faint acceleration. It would have been a traveler propelled by its own dissolution, silently vanishing as it escaped. The mathematical modeling was compelling. Simulations indicated that such a body, formed in a frigid environment, could retain its structural integrity long enough to reach another star system. Every anomaly in the data found a congruent explanation within this model. The absence of visible debris, the consistent motion, the precise trajectory. It was an elegant, minimalist, and complete hypothesis. However, elegance in science often conceals fragility. Critics quickly pointed out that cosmic radiation would degrade hydrogen ice far too rapidly. No crystal, however cold, could withstand the bombardment of interstellar space for tens of millions of years. It would have vaporized entirely long before reaching Earth, its perfection undone by the very void it was intended to traverse. Thus, the theory became a paradox. Hydrogen could explain everything except its own persistence. It shimmered like a mirage, an idea perceived through the heat of intense curiosity, beautiful yet intangible. And still, even in its failure, it deepened the enigma. Each discarded hypothesis left a clearer outline of what remained unknown. Perhaps Oumuamua was composed of something entirely novel, an unknown chemistry defying our established classifications, a substance blurring the boundaries between rock and vapor, between the known and the imagined. Ultimately, the hydrogen mirage revealed more about humanity than about the object itself. Confronted with the inexplicable, humans habitually construct theoretical bridges across the void, even knowing they may eventually collapse. By the time the debates surrounding nitrogen shards and hydrogen ice had subsided, the scientific discourse cooled into something more humble, less visionary, and more grounded in terrestrial restraint. After years of contemplation, one final possibility re-emerged, quiet and unassuming. Perhaps Oumuamua was simply what it initially appeared to be, a comet, albeit a peculiar one, a comet that had shed its dust. Within the taxonomic framework of solar systems, comets are celestial bodies characterized by intense activity and eventual dispersal. Icy remnants that awaken as they approach the sun, their frozen cores vaporizing into radiant tails. However, not all comets adhere to this predictable behavior. Some, scorched by countless orbital journeys, shed their outer layers and become spectral remnants. Dustless comets, hardened and diminished, leave behind only faint echoes of their former brilliance. If Oumuamua were such a celestial body, its unusual characteristics might dissolve into the natural variations observed in the cosmos. Its smooth surface, its nearly silent passage, its subtle acceleration, all could be attributed to a body stripped bare by time and distance. A wanderer so ancient that it had perhaps forgotten how to manifest its cometary nature. Astronomers reminded the world that the universe does not conform to neat repetitions. Each star system crafts its debris with unique proportions, its own specific blend of ice, silicon, and metal. A comet originating from another sun might easily differ from those cataloged in our own. Its gases could be more volatile, its dust finer, its surface darker or smoother. To our instruments, such a traveler would appear alien, not due to artificial origins, but because we had never encountered its kind before. The dustless comet hypothesis shifted the focus of the mystery inward. suggesting that what puzzled us about Oumuamua might stem not from its strangeness, but from our own limited experience. Its non-gravitational acceleration could be the faint exhalation of sublimation beneath a hardened crust, imperceptible but real. The cumulative effect of millions of years of interstellar drift, radiation, and micrometeoroid impacts. These forces could have sealed its surface, allowing minuscule outgassing jets to operate unseen. What appeared as precision might have been coincidence. What seemed intentional could have been physics engaging in artistic expression. Precedents for such phenomena existed. In 2016, Comet 332P E.A. Murakami shattered unexpectedly, its fragments twisting and accelerating erratically without visible plumes. The cause was not technology, but an asymmetry, uneven sunlight warming one side more than the other. Perhaps Oumuamua was an interstellar echo of that same delicate geometry, a fragment of ice tumbling through the darkness, caught between chaos and equilibrium. To many, this explanation offered a sense of release, restoring order to a narrative that had begun to sound overly mythic, a narrative driven by an insatiable human desire for meaning. It served as a reminder that nature's illusions can rival any act of deliberate design, and that the cosmos, governed by its own laws, is capable of generating wonder without conscious intent. Yet, even this plausible explanation carried its own undercurrent of disquiet. Each new model seemed to account for almost everything, yet never quite everything. Every hypothesis left a residual subtle dissonance between what the observational data indicated and what intuitive understanding suggested. The closer science came to understanding Oumuamua, the more it appeared to reflect humanity back at itself. Our curiosity, our skepticism, our innate longing for pattern amidst the vastness of the void. In the years following Oumuamua's fading into the darkness, its absence became as significant as its discovery. Telescopes turned their attention elsewhere. Scientific papers gave way to retrospective analyses. Yet, the fundamental question lingered like static beneath the steady hum of scientific progress. Science advances through embracing uncertainty. It does not silence mystery, but learns to coexist with it. Despite every published paper, every computer simulation, and every impassioned debate, Oumuamua resisted easy domestication by certainty. Each theory had elucidated a portion of the puzzle, but none presented a complete picture. Like a riddle that stubbornly retains its final unanswered line, the object remained suspended between established fact and speculation, leaving behind not resolution, but doubt, science's most enduring and faithful companion. In the quiet confines of observatories, the argument softened into a deep fascination. What had begun as a hurried attempt at classification evolved into something more gentle and contemplative. As one astronomer mused over coffee, "We haven't discovered an anomaly at all, just a category that doesn't yet exist." This thought felt profoundly liberating. Discovery, they realized, does not always fill the existing map. Sometimes it redraws its boundaries, leaving the center a blank space. Each theoretical framework had left its mark. The nitrogen fragment hypothesis explained the object's sheen, but faltered under the weight of probabilistic analysis. The hydrogen ice model captured the propulsion mechanism, but dissolved under the scrutiny of fundamental physics. The dustless comet theory restored a sense of order, but carried a subtle discomfort, as if the very tidiness of the explanation itself felt unconvincing. Every proposed solution circled back to a fundamental truth. Something remained incongruous, and perhaps that was the ultimate lesson. Regardless of the sophistication of our instruments or the precision of our mathematical models, the cosmos converses in silence. It reveals only what we are prepared to comprehend. For some, this silence was maddening. For others, it offered a form of grace. Oumuamua had transcended its status as a mere celestial object. It had become a mirror in motion, a cosmic koan, a question designed not for a definitive answer, but to rekindle our sense of wonder. It served as a potent reminder to the scientific community that curiosity is not the adversary of rigor, but its very source. From this realization, new aspirations began to form. The mystery itself became the impetus for further exploration. Project Lyra was conceived, a bold initiative to pursue what had already evaded us, to dispatch a craft with sufficient velocity to intercept the interstellar traveler and ascertain its true nature. Even if the pursuit were ultimately unsuccessful, it represented a symbolic act of defiance against the vastness of distance, a declaration that uncertainty is not surrender, but an invitation to explore. In his later reflections, Avi noted that humanity often searches for extraterrestrials, but primarily discovers reflections of itself, our fears, our pride, our profound longing to be acknowledged. This observation resonated deeply, extending far beyond the realm of astronomy. Every enigma, from the smallest subatomic particle to the most distant star, directs us back to that same reflective mirror, the human imperative to construct meaning, even in the absence of any guarantee of its existence. By the time Oumuamua had passed the orbit of Saturn, it was already beyond reach, too small, too faint, too swift to be contained. Telescopes worldwide strained against the darkness, attempting to track a single fading pixel as it receded, much like a heartbeat diminishing into the deep ocean. Even the Hubble Space Telescope, with its unwavering precision, could no longer resolve its form. The interstellar messenger had traversed the inner solar system in mere weeks, leaving behind only the arc of its trajectory and a profound silence filled with unanswered questions. For many astronomers, this loss felt intimately personal. They had witnessed the arrival of the first confirmed visitor from beyond our solar system, and now it was vanishing at a speed of 54 kilometers per second, exceeding the velocity of any human-made craft ever launched. The voyages drifting beyond the heliosphere seemed almost static in comparison, like slow-burning embers trailing the path of a fleeting spark. Oumuamua was more than just an object. It represented an unattainable threshold, a stark measure of our comparative smallness and lateness within the vast cosmic machinery. Yet, the concept of impossibility has always served as fuel for the scientific intellect. Where others saw an endpoint, engineers and visionaries perceived a formidable challenge. In quiet laboratories across NASA and the European Space Agency, a singular question began to take shape. What if we pursued it? The target was gone, but its path remained etched in the data, a scar of motion, a mathematical ghost still traceable across the solar system. If humanity could construct a vessel fast enough, intelligent enough, and deployed soon enough, perhaps it could intercept the object decades later, far beyond the Kuiper Belt, where sunlight is but a distant memory. The calculations were swift and brutally realistic. To overtake Oumuamua, a spacecraft would need to achieve speeds exceeding 70,000 miles per hour, shattering all previous records for propulsion. Conventional chemical rockets were inadequate. Even advanced nuclear designs strained under the immense energy requirements. The challenge was not merely technological. It was fundamental momentum, the need to escape the sun's gravitational pull and still possess sufficient power to pursue an object that no longer waited. Furthermore, Oumuamua offered no discernible signals, no radio beacon, no thermal trace, no magnetic whisper. It fled the solar system like a secret determined to remain untold. Even the most sophisticated models, run on supercomputers in Pasadena, Heidelberg, and Cambridge, eventually dissolved into probabilities, reducing its position to a cloud of uncertainty. The target had transformed into an abstract concept, a moving coordinate residing at the edge of faith. Nevertheless, the aspiration to follow persisted. It was no longer about capture, but about refusal, a refusal to let mystery vanish unpursued. "We cannot catch it," one mission engineer wrote, "but we can learn how to chase." This sentence became the quiet genesis of something new, a project that would seamlessly merge imagination with engineering, humility with audacity, and theory with unwavering resolve. They named it Project Lyra. To chase Oumuamua was akin to pursuing a shadow. Yet, humanity has historically demonstrated its greatest inventiveness when confronting the impossible. What began as frustration gradually transformed into determination. Out of that perceived distance and doubt emerged a plan as improbable as the object itself. Project Lyra, conceived by a collaborative group of astrophysicists and aerospace engineers at the United Kingdom's Initiative for Interstellar Studies. Their objective was both technical and poetic: to create a craft capable of achieving speeds sufficient to pursue an object that was irrevocably departing. The challenge was almost absurd. Oumuamua was receding from the sun at a velocity exceeding 26 kilometers per second. By the time the proposal was formalized in 2018, it was already billions of kilometers distant. Any undertaking would require a vessel capable not only of breaking free from Earth's gravitational hold, but also of accelerating towards the sun, harnessing its incandescent energy as a cosmic catapult. This endeavor would stretch the very limits of physics, thermal resilience, and human perseverance. To describe it as ambitious would be a gross understatement. To label it as audacious would be an accurate, albeit blunt, assessment. The architects of this vision commenced their work, as all innovators do, with the language of numbers. They meticulously calculated gravitational assists, the energy efficiency of deep solar plunges, and the thermal tolerance of materials currently known to humankind. Central to their concept was the Obath maneuver, a high-stakes strategy involving a probe's plunge towards a celestial body of immense mass, with its engines firing at the zenith of gravitational acceleration. The closer the descent, the greater the energetic yield. To reach Oumuamua, a probe might need to traverse within mere solar radii of the sun's photosphere, enduring temperatures exceeding 400 gangs, an unspecified unit of heat measurement. Conventional metals would liquefy. Protective shielding would need to be meticulously crafted from carbon composites and mirrored ceramics, engineered to deflect the sun's own intense radiance. As is often the case when imagination takes flight, alternative concepts began to materialize. Some scientists envisioned a laser-driven light sail, propelled by terrestrial beams to a significant fraction of the speed of light, echoing the speculative musings of Lowe. Others proposed fusion microprobes, theoretical propulsion systems capable of sustained thrust for extended durations. Each design articulated a similar spirit of defiance. We may not achieve our objective, but we will not cease in our efforts. Soon, the mission's operational blueprint began to resemble a carefully orchestrated performance, a celestial ballet of gravitational fields and precisely timed maneuvers, charting a course from Earth to Venus, back to Earth, onward to Jupiter, and finally, towards the Sun. Each planetary interaction would involve the exchange of momentum, akin to a relay, compounding the craft's velocity with every pass. Upon its final plunge, the spacecraft would be ejected outward from the Sun at speeds surpassing 100 kilometers per second, an alloyed projectile aimed at a distant, fading coordinate at the edge of observable space. If initiated around the year 2030, it might reach its projected convergence point sometime in the 2050s, a quest spanning an entire generation. Detractors denounced the endeavor as folly, a monument to humanity's infatuation with the intangible. Yet, others perceived something more profound: the dawn of interstellar engineering, a bold assertion that curiosity itself could be weaponized against the immense void of the cosmos. Even if Oumuamua remained perpetually elusive, the technological advancements forged in this pursuit, heat-resistant shielding, autonomous navigation, hybrid propulsion systems, would fundamentally redefine the scope of humanity's future aspirations. To conceptualize such a mission was to transform potential setbacks into forward momentum and uncertainty into tangible architectural designs. While Oumuamua might forever remain beyond grasp, Project Lyra's true objective was never solely about attainment. Its purpose was philosophical: to demonstrate that ignorance is not synonymous with surrender. Between the known and the lost, humanity's inherent drive is not to withdraw, but to pursue, to calculate, and to construct. To reach Oumuamua, a direct trajectory was impossible. The cosmos lacks conventional thoroughfares, but it possesses inherent currents. These are gravitational rivers, winding through the void, invisible yet precise, awaiting those bold enough to navigate them. The engineers behind Project Lyra christened their design the Planetary Ballet, a sequence of intricate close encounters choreographed with mathematical precision. Each maneuver entailed siphoning a minuscule fraction of velocity from the planets themselves. The journey would begin, paradoxically, with a descent. Following its launch, the spacecraft would not flee the sun. Instead, it would dive directly towards it. This initial step in the celestial dance would guide the craft towards Venus, whose gravitational pull would draw it inward, reshaping its orbital path into a tighter spiral. This initial embrace would impart a modest increase in velocity, a few precious kilometers per second, imperceptible to a human observer, but decisive in the grand calculus of celestial mechanics. From Venus, the probe would return to Earth for another gravitational assist, slingshotting behind the planet to borrow a portion of its orbital momentum. Much like a dancer building momentum with each turn, the craft would accumulate energy not through brute force, but through precise alignment. The third phase of the choreography would bring it to Jupiter, the colossal conductor of this cosmic symphony. By passing behind the giant planet, threading its way through a corridor of gravitational power, the spacecraft would harness Jupiter's immense pull to execute a final, daring dive towards the sun. This descent was not an act of recklessness, but a strategy refined to the brink of peril. The closer one approaches the sun, the greater the potential energy acquired. The deeper the dive, the more potent the subsequent outward thrust. At its nadir, the Obath effect would amplify every spark of applied propulsion. Igniting its engines at perihelion, the point of maximum velocity and gravitational intensity would transform every droplet of propellant into a tempest. For a few agonizing minutes, the probe would traverse a crucible of heat more intense than primal creation. As incandescent plasma clawed at its protective shell, the spacecraft would unleash its engines. In that critical instant, gravity itself would transform into an ally, propelling it outward at velocities exceeding 100 kilometers per second. It would become the fastest object ever engineered by human hands. However, to reach this point, it would have to endure an environment where no machine had previously survived. Even the Parker Solar Probe, humanity's most audacious emissary, had only grazed the sun's outer atmosphere. The craft designed for Project Lyra's mission would plunge far deeper, potentially within 3 solar radii, where solar radiation becomes a weaponized force and aluminum would vaporize within seconds. The heat shield, a gleaming mosaic of carbon composites and actively cooled conduits, would deflect incoming radiation as if it were armor forged for a star. Beneath this radiant barrier, the probe's instruments would lie dormant, folded and dark, awaiting the cessation of the solar storm. Upon emerging from this fiery ordeal, it would no longer be in a state of descent, but would be liberated, streaking through the Kuiper belt, accelerating faster than any artifact ever constructed. The celestial dance would conclude, and the pursuit would commence. Ahead lay decades of silence, a frigid voyage through the blackness towards a vanishing point that might never be attained. The probabilities of interception were exceedingly slim, perhaps as low as 1 in 1,000. Yet, the pursuit itself promised to yield something more significant than mere success: a novel methodology for escaping the sun's gravitational embrace. The engineers discussed the trajectory with a near sacred reverence, as if they were composers orchestrating motion itself. Each planet served as a collaborator, each gravitational slingshot a pirouette upon gravity's grand stage. The tempo was measured in orbital periods, the rhythm in centuries. And through this vast, invisible choreography, humanity's most ancient impulse, to follow what flees, was translated into the precise language of mathematics. The culminating phase of Project Lyra's elaborate design represented the pinnacle of peril. It involved a maneuver so audacious that even the lexicon of engineering struggled to encompass its magnitude. To pursue Muir, the craft would have to relinquish its defenses entirely to the sun's gravitational dominion, plunging almost to its very surface, and then ignite its engines at the precipice of oblivion. Engineers, with understated precision, termed this the solar burn. However, within internal documentation and mission logs, it garnered a more poetic appellation: fire by the sun. At perihelion, the moment of closest proximity, the probe would achieve unprecedented velocity, traveling at nearly 400,000 kilometers per hour. For a brief, blinding interval, it would inhabit a sky dominated solely by the sun. Its light would be so ferocious that even a sliver of exposed metal would be vaporized in mere seconds. No spacecraft had ever ventured into such proximity. Even the Parker Solar Probe, humanity's most daring emissary, maintained a distance 3 times greater from the inferno, exercising caution before a star that offers no forgiveness. To endure, the probe would require armor bordering on alchemical mastery. Its shield, a carbon-carbon shell layered with mirror-bright ceramics, would refract 97% of the incoming solar radiation. Beneath this dazzling surface, a network of liquid coolant would circulate through microscopic channels, absorbing heat and dissipating it through radiators strategically positioned in the deepest shadows. Every gram of mass had to serve a critical purpose. There was no allowance for superfluous components. It was a vessel engineered not for comfort or repair, but for a singular act of sustained endurance. Then there was the challenge of timing, a problem as formidable as the physics itself. The Obath maneuver necessitated ignition at the precise instant when velocity and gravitational forces converged in a state of violent harmony. Igniting the engines too early would result in the craft being pulled back into the sun. Firing them too late would render the thrust ineffective, slipping past the point of optimal advantage. The margin for error was less than 2 seconds. Human reflexes were rendered irrelevant. Computers would dictate the moment of survival. From Earth, this critical event would transpire unobserved. The sun's overwhelming glare would obscure all instruments, and its plasma storms would obliterate communication signals. Mission control would be plunged into a silent vigil, staring at static, acutely aware that somewhere within that blinding void, the probe was either successfully executing its burn or succumbing to destruction. Then, perhaps hours later, a faint signal would pierce the silence, a fleeting flicker of telemetry, a heartbeat transmitted across light minutes of distance. The message would be concise, yet profoundly significant. Escape confirmed. Humanity would have achieved what nature itself rarely attempts, utilizing a star as an instrument of acceleration. Following the intense solar burn, the spacecraft would drift outward into the eternal cold. Its engines would be inert, its shields scorched and vibrating, bearing the indelible scars of the sun upon its surface, a spectral artifact illuminated by the very heat it had assimilated. Behind it, the solar furnace would recede, diminishing to a single point of light. Ahead, somewhere beyond the orbits of Neptune and Pluto, awaited Oumuamua, the once unreachable, now infinitesimally closer. Once its engines fell silent and the solar inferno faded into its wake, the probe from Project Lyra would enter a state of stillness previously unknown to any human-made machine. It would be a silence so profound it could be mistaken for eternity. From that point forward, its journey would unfold not in hours or days, but across decades. It would embark on a slow pilgrimage through the interstellar dusk, propelled solely by the residual memory of sunlight. It would sail outward, passing Neptune and leaving behind the radiant order of the planets for the frigid chaos of the Kuiper Belt. Here, ancient fragments of creation drift in orbits undisturbed since the solar system's inception. In this desolate expanse, the craft would glide past celestial bodies that have never known warmth, icy sentinels predating Earth itself, until it reached the heliopause, the invisible boundary where the sun's influence wanes and the galaxy begins. To breach this frontier would signify an unprecedented achievement, a vessel not merely escaping its star, but actively pursuing a traveler that had once originated from beyond it. By that time, Earth would have undergone transformations beyond current comprehension. The scientists who conceived the mission would have long since passed into dust, their descendants inheriting the protracted vigil. Signals would traverse the vastness of space at light speed, their transmission times extending from minutes to hours, then days, and finally, weeks. Each transmission, faint and delayed, would carry the echo of effort across generations. The mission would transcend its status as a mere expedition, evolving into a testament, a proof that the relentless pursuit of knowledge can outlast its initial proponents. Somewhere far ahead, Oumuamua would remain an elusive phantom, perpetually in motion, perpetually receding, a glimmer just beyond reach. Yet, the ultimate objective had never been its capture. Project Lyra was as much a preparatory exercise as a chase, a means of equipping humanity with the skills to extend its reach across the stellar expanse. Success would not be measured in images or collected samples, but in profound transformation, the emergence of a species learning to navigate the interstellar void with deliberate intent. The act of aiming was sufficient. The process of evolution itself constituted victory. In the distant, cold expanse, the probe would eventually enter the same galactic currents that had once conveyed Oumuamua to our solar system. Two travelers sharing the same invisible tide, one born of another sun, the other of ours. Their paths might never converge, but their trajectories would resonate, each tracing the wake of the other across the boundless ocean of starlight. By the time the probe ventured into true interstellar space, its signal would have attenuated to imperceptibility. Its internal systems would cool, its sensors would slumber, and its internal pulse would gradually fade to silence. Nevertheless, within that silence, it would have fulfilled its ultimate purpose. Humanity would have brushed against the threshold of eternity, leaving behind a whisper, a fragment of will transmuted into motion. Long after Oumuamua had vanished into the frigid darkness, the telescopes remained vigilant. The initial fervor that had once electrified observatories gave way to a more sustained, quiet vigilance, a collective breath held in anticipation of the unknown. Something fundamental had shifted. Humanity now understood that the stars could indeed dispatch visitors, unannounced, uninvited, and ephemeral. Astronomers bestowed upon them the designation interstellar objects, while the public, with greater poetic sensibility, referred to them as messengers. Consequently, the paramount question evolved, not what was it, but rather, when will the next one arrive? To await such a traveler necessitated the cultivation of a cosmic form of patience. These celestial wanderers cannot be predicted. They can only be detected. Their approach is swift and clandestine. By the time telescopes register their fleeting glint, they are already halfway through their journey. Each discovery represents a race against time, a pursuit initiated too late. In response, the European Space Agency proposed a concept that was both elegantly simple and remarkably audacious. If we are incapable of intercepting them as they depart, we must be prepared for their arrival. They christened this initiative the Comet Interceptor. Its purpose was elegance in its purest form, a spacecraft launched not in pursuit, but in anticipation. The vessel would be positioned at Lagrange point L2, a delicate nexus of gravitational equilibrium, 1,000,000 miles beyond Earth, where the constant interplay of sunlight and shadow maintains an eternal truce. There, it would remain in a state of patient readiness, awaiting the next interstellar visitor to announce its presence. Upon that moment, the probe would awaken, bifurcate into 3 smaller, independent craft, and swarm the newcomer from multiple vantage points, thereby achieving the kind of close encounter observation that humanity had missed twice before. Unlike Project Lyra, which endeavored to chase a phantom that had already vanished into the abyss, the interceptor would assume the role of a sentinel, lying in quiet ambush. Its mission was not one of pursuit, but of preparedness. The European Space Agency slated the launch for the year 2029, intending to share the ride with another outbound mission. Concurrently, on Earth, a new eye was opening. NASA's Vera Rubin Observatory, meticulously designed to scan the southern celestial hemisphere each night, cataloging billions of stars and detecting every subtle flicker of motion among them. Somewhere within that vast archive of light, another messenger might already be inbound, unseen, unimagined. Thus, the night sky transformed into something entirely new, a waiting room for revelation. The gentle hum of instruments became the sound of hope, algorithms sifting through cosmic patterns with the dedication of monks translating celestial light. Following the encounters with Oumuamua and Borisov, designated as 3-Eye Atlas, curiosity had adopted a new posture. It was no longer the desperate sprint of reactive measures, but the poised silence of attentive observation. Humanity, once the chaser, had now become the listener. The Comet Interceptor was not engineered for pursuit, it was built for waiting. And in the grand language of the cosmos, waiting itself is a profound form of motion, tense, deliberate, and vibrantly alive. Suspended at Lagrange point L2, a distance of 1.5 million kilometers from Earth, the spacecraft would hover in a state of gravitational equilibrium, perpetually orbiting the Sun without ever drifting away. There, Beyond the faint echo of Earth's magnetic field, it would maintain its silent vigil, a sentinel poised on the razor's edge between sunlight and shadow. Its designers understood a fundamental paradox. Space is too vast to be exhaustively searched and too unpredictable to be effectively commanded. The only viable approach to encountering the unknown was to remain perfectly still, allowing it to reveal itself. The interceptor's mission embodied a form of cosmic patience, a machine coiled in quiet readiness, its instruments scanning all directions, its algorithms in a state of light slumber. When the next interstellar wanderer traversed the outer solar system, its presence momentarily flaring against the profound darkness, the craft would awaken. Within seconds, it would triangulate a trajectory, compute an intercept course, and ignite its engines. The trap would spring, not with aggression, but with exquisite timing, spanning millions of kilometers. However, this was not a snare of conquest, but a gesture of focused attention, a solemn promise that the next visitor from beyond would not slip away unobserved. Whereas Project Lyra had been conceived from a place of longing and loss, the Comet interceptor was born from the principle of readiness. It would carry 3 deployable probes, each equipped with sensory and analytical capabilities, a fragment of curiosity designed to detach and envelop the target like petals unfurling around a fleeting bloom. For a brief, precious interval, humanity would be granted the opportunity to observe the unknown from 3 distinct perspectives simultaneously. The data acquired during this singular encounter could potentially outlive its creators, fundamentally reshaping our understanding of both comets and the interstellar void from which they emerge. Yet, even this meticulously crafted plan harbored an irony befitting its cosmic scale. We had engineered a trap for mystery itself, but mystery does not always consent to be apprehended. What if the next visitor, much like Oumuamua, offered no discernible story, no visible glow, no discernible clue? What if it arrived not as a comet, but as something entirely outside our current classificatory frameworks? Neither ice nor rock, but a phenomenon for which our language has yet to evolve. In such a scenario, the perfectly sprung trap might yield only silence. Perhaps therein lies the deeper lesson. The interceptor was never truly about capture. It was about presence. It represented a fundamental shift from arrogance to humility, from a desire for command to a posture of attentive observation. After millennia of demanding answers from the stars, humanity had finally learned to wait for them instead. The universe, indifferent and infinite, does not yield to insistence. It speaks only to patience. And so, the probe would drift, year after year, through the gentle whisper of the solar wind. Dust would invisibly accumulate on its panels, its sensors would dim and begin to dream. Yet, it would not truly sleep. Its circuits would remain poised in anticipation, a metallic consciousness maintaining its vigil in the darkness, believing that one day something would disturb the profound silence once more. If it possessed the capacity for thought, perhaps it would not experience loneliness, but a deep sense of purpose. Waiting, after all, is a form of faith, the unwavering belief that what is silent now will, in time, speak. Humanity has come to embrace that same faith. Behind every telescope, behind every listening dish aimed at the cosmic static, lies that same quiet conviction. The next signal will arrive. The night sky has perpetually been a promise etched in silence, a vast, wordless assurance that something is indeed moving out there, unseen but inevitable. Every star represents a possibility, and every shadow harbors a waiting messenger. And somewhere, beyond the reach of our current instruments, Another traveler is already en route, a fragment from another stellar system, carrying the chemical signatures of a different dawn. We cannot perceive it yet, but the fundamental laws of celestial motion dictate its eventual arrival. Astronomers refer to it simply as the next one. They remain uncertain of its form, its velocity, or the narrative its constituent minerals might hold, but they are confident in its existence. In the quiet arithmetic of the galaxy, hundreds of billions of stars cast their debris into the void. By sheer statistical probability, a select few of these wanderers must traverse our solar system each decade. Oumuamua was not an anomaly. It was a precursor, the first drop of rain preceding an interstellar storm. Others will follow, each bearing whispers of alien chemistry, each shaped by a world we may never witness. When that next visitor arrives, our observational capabilities will be far more refined. From its vantage point in Chile's Atacama Desert, the Vera C. Rubin Observatory will sweep the heavens each night, its immense 3,200 megapixel eye capturing every fleeting glint and subtle drift across the southern sky. Somewhere within that deluge of data, a faint streak, a shifting pixel, will betray the signature of motion originating from beyond our immediate celestial neighborhood. Within hours, sophisticated algorithms will trace its trajectory backward, revealing what the human eye cannot discern, an orbit that commences not within the sun's influence, but from a point beyond it. And this time, we will not be caught unprepared. Far beyond Earth, the Comet interceptor will awaken from its prolonged dormancy, its solar panels faintly glinting in the profound darkness. It will pivot towards the approaching newcomer, its instruments unfolding like delicate wings. 3 smaller probes will then separate, forming a line for pursuit, fanning outward to encompass the visitor as it passes. Regardless of whether the target proves to be composed of ice, rock, or something entirely defying these classifications, we will not allow it to fade unmeasured. For the first time, we will engage with the unknown in real time, face to face, as it traverses our sunlit domain. And when that moment arrives, its impact will resonate far beyond laboratories and mission control rooms. Across continents, children will step outside, tilting their faces upward towards the sky. The news reports will focus on trajectories and spectral analyses, but what they will truly feel is something far more ancient than science, a quiet awe and an instinctive realization that the sky is not, after all, empty. Some will dream of propulsion systems, of interstellar sails, and of communication signals. Others will simply gaze into the stars, sensing a profound possibility that somewhere, someone might be looking back. This state of readiness, this act of anticipation, of attentive observation, marks a significant shift. It transcends mere technological advancement. It represents a fundamental change in our character. Humankind has evolved not only to contemplate the unknown, but to actively prepare for its revelations. Every observing instrument, every sophisticated sensor, every fragment of information gleaned from the vast expanse of space contributes to a singular, enduring entity. It is a civilization extending its perception into the cosmic void. We might never ascertain the origins of these celestial emissaries, nor whether their existence is a product of chance or deliberate creation. Nevertheless, through them, we gain insight into the very fabric of existence, worlds forming, disintegrating, and momentarily intersecting across the immensity of time. The subsequent arrival will be unannounced, gliding through the solar radiance, silent and self-contained. Its transit will be briefer than a fleeting memory, and when it arrives, we will not embark on a reckless pursuit into the darkness. Then, as invariably occurs, silence will descend, profound, absolute, and eternally patient. The brilliance of these discoveries will recede, the final transmission will return through static, and the displays will dim. Somewhere, the newest arrival will dissipate into the solar winds, its trajectory dissolving into particles finer than any thought. The instruments will cease their work. The heavens will resume their steady, unhurried, and eternal cadence. In that tranquil aftermath, humanity will once again grasp the true meaning of distance, the immeasurable chasm separating celestial bodies, the epochs that lie between these ephemeral conjunctions of matter and wonder. Yet, this silence is not an absence. It is the drawn-out breath of the cosmos, the inhalation preceding its next grand exhalation. Each interstellar voyager is a pulse against that profound stillness, a gentle reminder that creation is an ongoing process, simply unfolding at a pace too slow for our perception. The stars are not inert. They dispatch their envoys in the language of patience, and we, constrained by our finite lifespans, must learn to await them with reverence. Far beyond the orbital path of Neptune, Oumuamua navigates the abyss, a fragment of alien memory fading into the black. Elsewhere, along a different trajectory, 3 separate Atlas probes drift in serene isolation, their once brilliant comas long since dispersed. Both are now silent, their signals lost to the void. Yet silence, too, possesses a voice. They remind us that we, much like them, are wanderers, a delicate planet orbiting an unremarkable star, propelled by the same insatiable curiosity that compelled us to direct our gaze skyward. Between their receding trails lies an unexpected solace. What once felt like solitude now resonates as connection. The universe, immense and seemingly indifferent, reveals an almost tender aspect, a shadowy cradle that cradles our faint luminescence. Even in this hushed realm beyond words, the cosmos teems with life. Subatomic particles resonate. Stellar bodies murmur through the intricate network of gravity. Galaxies drift like nascent thoughts across the canvas of time. Stillness, we discover, is merely motion attenuated. Despite our extensive investigations, the cosmos rarely offers direct answers. It bestows upon us fragments, fleeting glimpses, and inquiries that outlast their discoverers. However, perhaps this restraint is its most profound gift. Significance is not found at the terminus of a signal, but is embedded within the very act of listening, to construct, to anticipate, to marvel. This is how a species learns to feel at home. And so, we shall persist in our listening. The telescopes will maintain their unwavering watch, their glassy eyes fixed upon the infinite darkness. Somewhere, another traveler is already en route, currently unseen, traversing the gulf between the stars. When it arrives, we will perceive it initially not as a data stream, but as a subtle vibration in the quiet, a faint heartbeat heralding the next narrative. Until that moment, the universe holds its breath, and beneath that vast, eternal stillness, so do we. And now, this expedition concludes. The instruments fall quiet, the telescopes are retired, and the data streams dissolve into recollection. What endures is the echo of a question that has accompanied us since the nascent spark of our curiosity. What drifts between the stars when no one is observing? We have encountered 2 such answers: Oumuamua and the 3 Atlas probes. Each traversed our solar system like a thought passing through the galactic consciousness, one diminutive, one immense, one departing with haste, another still approaching. They might be nothing more than wandering bodies of rock and ice, or they could represent fragments of a design beyond our current comprehension. Yet, Whether originating by chance or by design, their passage has transformed us. From the quietude of observation emerged a drive for action. Project Lyra, conceived to pursue the unattainable. The Interceptor, engineered to await with unwavering patience. One forged in the spirit of pursuit, the other in the discipline of attentive listening. Between these endeavors lies the measure of our humanity, restless inquiry, perpetually poised between knowledge and awe. Perhaps this is the true discovery, not the objects themselves, but the reflection they presented to us. We gazed outward and perceived our own image, fragmented among the stars. The innate urge to explore, to reach beyond what is tangible, to comprehend what cannot be possessed. In our own manner, we are akin to those emissaries, fragments journeying through the darkness, carrying vestiges of origin and intent. One day, long after these words have vanished, one of our own creations, a probe, a relic of human ingenuity, will drift beyond the gravitational embrace of our sun. It will traverse the constellations until another civilization, perhaps centuries hence, detects its faint transmission and poses the question, "Who sent this?" In that instant, we will have answered Oumuamua's silent query, becoming the visitor we once sought to comprehend. The universe does not hasten its responses. It communicates gradually through orbits and celestial mechanics, through the silent ballet of gravity and light. Every comet, every signal, every moment of quietude is part of this ongoing dialogue. And though our understanding may be partial, it is sufficient to know that we are perceived, even if the reply takes millennia to arrive. Therefore, we continue to listen. We continue to imbue our questions into vessels and observatories, dispatching them outward like messages cast into the sea. And when the next celestial light graces our sky, we will look upward once more, not with apprehension, but with a sense of recognition. For every reverberation beyond the light is a reflection of ourselves, softly calling from the darkness, reminding us that to wonder is to belong.